And so we start our very first problem of Griffiths, and it is a relatively simple problem. We have the distribution that we were dealing with before of people's ages, and we want to compute three different things. So let's just start with part A, which is we want to compute the average of j squared and the average of j, and then squared. Fortunately, once again, English is a little bit incapable of determining the difference between these two. So we already have the formula for the average of any value. We know that the average age can be computed as a summation in j of a given age multiplied by the probability of that age. So if we were to go on and find our two intended values, let's start with j squared. The average of j squared is the same thing, except instead of the age j, we just substitute with the age squared, which is j squared, multiplied by the same probability of j. And if you were to add this out, this becomes 1 over 14 times 14 squared plus 15 squared plus 3 times 16 squared plus etc, etc, etc. And if we were to plug this in fully, we would get 459.57. So that's our first one. Let's go with the second one now, which is the average of j and then that squared. And this, we can simply take our formula from up here and throw a bracket around it. So this equals the summation in j of j times p of j. And then we take this whole thing and square it. And if we plug this into the calculator, we would get 441. So let's move straight on to part B, which is to determine delta j for each j. Well, we know that from earlier on, we know that delta j was something we defined to equal j minus delta j. So as an example of this, let's start with the j equals 14 case as an example. For j equals 14, well, delta j in this case, let's denote it as delta, let's denote it as delta j sub 14, and this will be equal to j, which is the age, which is 14, minus the average of j, which we calculated earlier up here. It is just the square root of 441, so minus the square root of 441, and this ends up being -7. And then we can go down and kind of do the same thing for all of the other ones. We just replace 14 with 15, and then 16, 22, 24, 25, etc. Kind of a trivial math exercise, we'll leave it at that. Part C, we want to use our results from part A and part B to check equation 1.12. And what equation 1.12 was the setup for the standard deviation, where we said that the standard deviation is equal to the square root of j squared average minus j average squared. And we kind of already have the answer here because we already have these two terms. This is just equal to the square root of j squared averaged, which is 459.57, subtracted by the average of j and then squared, which is 441. Plug this into a calculator and we get 4.3. And one way to verify that this is true is we can actually go and plug our data set into a calculator, into a graphing calculator, and what we will find is that indeed for this distribution, the standard deviation is in fact 4.3.